Hello and welcome to episode 10 of my sports and exercise science series. We're going to be following on from episode 9 by beginning to learn about 4 new topics. These include what blood is, the purpose and function of blood, the composition of blood, and finally, blood pressure. As the cardiovascular system is such a huge topic, I've decided to split the cardiovascular system into 2 different episodes. If you're more interested in learning about the heart, how it functions, the cardiac cycle, cardiac output, blood vessels, and veins, skip to the next episode where all of this is covered and more. The cardiovascular system is also referred to as the circulatory system and is responsible for delivering nutrients, oxygen, and water to tissues, as well as transporting hormones and enzymes around the body. It also takes waste products such as carbon dioxide and lactic acid away from the tissues of the body to be expelled or broken down. The cardiovascular system consists of 3 components. Firstly, we have blood, which is carrying oxygen and nutrients around the body, the heart, which acts as a pump to propel the blood around the body, and finally, blood vessels, which provide tubes for the blood to travel through on its journey to and from the heart. Now let's take a look at blood. Blood is a thick, red-coloured fluid that will be bright red when it is oxygenated and darker red when it has been deoxygenated. Blood accounts for around 8% of our body weight, and on average, an average male has a blood volume of 5 to 6 litres, and a woman has an average blood volume of 3 to 4 litres. So, what are the functions of blood? The primary function of blood is to deliver oxygen and nutrients to and remove waste products from the body's cells. But that is only the beginning of the story. The specific functions of blood also include defense, distribution of heat, and maintenance of homeostasis. Let's firstly talk about transportation. Nutrients from the food you eat are absorbed in the digestive tract. Most of these travel in the bloodstream directly to the liver, where they are processed and released back into the bloodstream for delivery to body cells. Oxygen from the air you breathe diffuses into the blood, which moves from the lungs to the heart, which pumps it to the rest of the body. Also, endocrine glands scattered throughout the body release hormones into the bloodstream, which carries them to distant target cells. Blood also picks up cellular wastes and byproducts and transports them to various organs for removal. For instance, blood moves carbon dioxide to the lungs for exhalation from the body, and various waste products are transported to the kidneys and liver for excretion from the body in the form of urine or bile. Let's now move on to defense. Many types of white blood cells, external threats, such as disease-causing bacteria that have entered the bloodstream in a wound. Other white blood cells seek out and destroy internal threats, such as cells with mutated DNA that could multiply to become cancerous, or body cells infected with viruses. When damage to vessels results in bleeding, blood platelets and certain proteins dissolved in plasma interact to create clots which block the ruptured areas of the blood vessels involved. This protects the body from further blood loss. Finally, we have maintenance of homeostasis. Body temperature is regulated via a negative feedback loop. If you are exercising on a warm day, your rising body core temperature would trigger several homeostatic mechanisms, including increased transport of blood from your core to your body's periphery, which is typically cooler. As blood passes through the vessels of the skin, heat would be dissipated to the environment, and the blood returning to your body core would be cooler. In contrast, on a cold day, blood is diverted away from the skin to maintain a warmer body core temperature. In extreme cases, this may result in frostbite. Blood also helps to maintain the chemical balance of the body. Proteins and other compounds in blood act as buffers which help to regulate the pH of body tissues. Blood also helps to regulate the water content of body cells. There are 4 basic components that comprise human blood: plasma, red blood cells, white blood cells, and platelets. Red blood cells represent 40 to 45% of your blood volume. They are generated from your bone marrow at a rate of 4 to 5 billion per hour. They have a life cycle of around 120 days in the body. Platelets are an amazing part of your blood. Platelets are the smallest of our blood cells and literally look like small plates in their non active form. Platelets control bleeding. Whenever a wound occurs, the blood vessel will send out a signal. Platelets receive that signal and travel to the area to transform into their active formation, growing long tentacles to make contact with the vessel and form clusters to plug the wound until it heals. Plasma is the liquid portion of your blood. Plasma is a yellowish colour and is mostly made up of water, but it also contains proteins, sugars, hormones, and salts. It transports water and nutrients to your body's tissues. White blood cells, also known as leukocytes, only account for about 1% of your blood. They are very important, however. White blood cells are essential for good health and protection against illness and disease. Like red blood cells, they are constantly being generated from your bone marrow. They flow through the bloodstream and attack foreign bodies, like viruses and bacteria. They can even leave the bloodstream to extend the fight into tissue. Let's conclude this episode by learning about blood pressure. So first off, what is blood pressure? Blood pressure is described as the pressure that the blood exerts on the artery walls. It is dependent on the amount of blood in the artery, which in turn is dependent on the cardiac output. This is the amount of blood leaving the heart. Blood pressure is also affected by the amount of force the artery walls exert on the blood. This force is referred to as peripheral resistance. The contraction of the ventricles introduces a wave of pressure onto the arteries that is then needed to propel the blood around the arterial system. The pressure of blood will be greater in the arteries close to the heart. So, it will be under the highest pressure in the aorta and then the arteries. Blood pressure drops significantly in the arterioles and is negligible in the capillaries and veins. So let's recap. Blood pressure is the pressure that the blood exerts on artery walls, and blood pressure is dependent on two factors: cardiac output, which is the amount of blood leaving the heart, and peripheral resistance, which is the force that the artery walls exert on the blood. When you get your blood pressure measured, you'll notice there are two numbers, a top number and a bottom number. Systolic blood pressure is the top number. This is the highest level your blood pressure reaches when your heart beats, forcing blood around your body. Diastolic blood pressure, which is the bottom number, is the lowest level your blood pressure reaches as your heart relaxes between beats. Blood pressure is measured in millimeters of mercury, known as mmHg. If the first number is 120 and the second number is 80, this would be written as 120 over 80 mmHg, and you'd call it 120 over 80. Once you know your numbers, you can use a blood pressure chart to see what they mean and if your blood pressure is within a healthy range. Charts are suitable for adults of any age, as the cutoff point for diagnosing high blood pressure doesn't change with age. Please note that at the time of recording this video, I'm using the UK blood pressure chart as a guide for the following information. Different countries do differ with blood pressure reading information and definitions. In the UK, a reading of 140 over 90 or over indicates you may have high blood pressure. Most doctors use 140 over 90 as the cutoff point for diagnosing high blood pressure, known as hypertension. This is the point where your risk of serious health problems goes up. They may prescribe medications and advise you to make lifestyle changes to bring your blood pressure down. The next range is 120 over 80 up to 140 over 90. This is known as pre-high blood pressure, or also called high normal blood pressure. This is not high blood pressure, but is a little higher than optimal. Next, we have 90 over 60 up to 120 over 80. Known as ideal blood pressure, also called normal blood pressure. Readings between this blood pressure reading range are healthy, and at this level you have a much lower risk of heart disease and stroke. Finally, 90 over 60 or lower indicates you may have low blood pressure. Low blood pressure usually isn't a problem, but sometimes can make you feel faint or dizzy, or could be a sign of another health problem. Again, as a disclaimer, all the information I'm using and guidance is from the UK ranges and recommended guidance, which may differ to other countries. This information is to give you a general educational overview of the ranges and what these ranges mean. As a sports and exercise scientist, you may find you have to take a client's blood pressure reading. If you've never taken a blood pressure reading before, please be advised that a single high reading doesn't necessarily mean your client has high blood pressure, as many things can affect blood pressure throughout the day, such as temperature, the time of last consumption, and emotions such as feeling stressed. As a personal trainer, I've had several occasions where I've taken a blood pressure reading of a new client and immediately been alarmed to see a dangerously high blood pressure reading. It's your obligation as a professional to advise your client to see a doctor so the appropriate next steps can be taken. Once their doctor has properly assessed the issue, they can then write me a letter to state that the client is able to partake in physical activity and personal training. Or alternatively, the doctor may wish to take other courses of action, such as 24-hour blood pressure readings, ECGs, prescribe medication, or request other investigative measures. That concludes the 10th episode of my sports and exercise science series. I hope you've enjoyed this episode and don't forget to like and subscribe for more free and educational content. You've been watching UK Fitness Hub. I've been Travistarrant, and I'll see you in the next episode where we continue study on the cardiovascular system.